We're starting with slide number 18, and this is from the PowerPoint set for Chapter 2, Part B. So Chapter 2B, slide 18. The first thing is to make sure that you know the definition of organic molecules. So it's an organic molecule if it contains both carbon and hydrogen together. So therefore, carbon dioxide, which contains carbon but not hydrogen, and carbon monoxide, which contains, again, carbon but not hydrogen, are considered inorganic chemicals, okay? Carbon is electroneutral. So what that means is that it always shares electrons. It never gains or loses electrons. And because it has 4 valence electrons, or 4 electrons in its outer shell, it can form 4 covalent bonds with other elements. So that makes carbon very unique. There's a couple of other elements, at least one other element that can do that, but carbon is the one that it just works out better chemically. And I think it's just silicon, actually, silicon and carbon. But carbon is good for forming all of these organic molecules that we're going to study. Macromolecules is what you call them sometimes, because of the fact that it can form 4 covalent bonds. So the groups of biomolecules, or major organic compounds that we're getting ready to study, are carbohydrates, lipids, proteins, and nucleic acids. Many of these organic compounds are polymers. That means they're long chains of individual building blocks called monomers. For example, proteins are polymers, and the monomers or building blocks of proteins are amino acids. The synthesis reactions that form these molecules are called dehydration synthesis. It's called dehydration synthesis when a larger macromolecule is formed, like when 2 amino acids are joined to form a peptide. A dipeptide is what it would be called. But when you form a larger molecule by combining two or more of the monomers, it's called dehydration synthesis. And then the opposite or reverse of that is called hydrolysis. Lysis always means breakdown anyway. So when you break down, for example, let's say a polysaccharide, which is a chain of simple sugars. When you break down a polysaccharide into its individual glucose monomers or building blocks, that would be hydrolysis. So dehydration synthesis is the synthesis reaction that occurs, and hydrolysis is the breakdown reaction that occurs. So if you look down here at the bottom at picture C, in fact, let's blow it up so you can see it better. In picture C, you're looking at, on the left, you're looking at the molecules glucose and fructose, which are both monosaccharides or simple sugars. So they're carbohydrates, but they're in the class of simple sugars. So you've got these 2 simple sugars, and the fructose is going to have a hydrogen removed, and the glucose is going to have a hydroxide removed, OH. So OH will be removed from glucose, H will be removed from fructose, and that will leave a place for glucose to form a covalent bond with fructose. And it will also remove the OH and the H, which will form water. So when glucose combines with fructose by a dehydration synthesis reaction, water is removed, so water becomes a product. That's where dehydration comes from. And then the 2 simple sugars, glucose and fructose, are joined, and that forms sucrose, which is a disaccharide. It's also the chemical that we call table sugar. So table sugar is sucrose. So dehydration synthesis combines glucose and fructose to form sucrose, and then hydrolysis will take the water and add a hydrogen and an OH and break apart the sucrose into fructose and glucose by adding the water back to the place where they're joined, where they form a covalent bond. So at this intersection right here, you're going to add a hydrogen there and an OH there, and that will break apart the sucrose into fructose and glucose, and that is hydrolysis. So anytime that you have any of these large molecules that we're studying, whether they're carbohydrates, lipids, proteins, or nucleic acids, when they break down, it's called hydrolysis. And then when the larger ones are made or synthesized, we call it dehydration synthesis. All right, carbohydrates include sugars and starches, as well as some structural carbohydrates that we find in the cell walls of certain living things. But carbohydrate, the word carbohydrate tells you chemically the elements that compose carbohydrates. Carbo is for carbon, hydra is for hydrogen, and anytime you have ATE, 8, on the end of the chemical name, that means it has oxygen. So carbohydrates contain carbon, hydrogen, and oxygen, and the ratio of hydrogen to oxygen is 2:1. You always have twice as many hydrogens as you do oxygen atoms. There are 3 classes of carbohydrates: monosaccharides, which are just simple sugars, one single sugar, and they're the monomers of carbohydrates. Disaccharides are 2 sugars or 2 monosaccharides chemically joined, and polysaccharides are chains of many simple sugars, many monosaccharides. And polysaccharides are polymers made up of monosaccharide monomers. So the building blocks of polysaccharides are monosaccharides. Okay, so examples of monosaccharides are going to be ribose and deoxyribose. These contain 5 carbon atoms. They are pentose sugars because they're shaped like a pentagon. And so they have 5 sides. And then glucose and fructose, and another one called galactose. Now, the glucose is the most important one because glucose is blood sugar in humans and other animals. These are hexose sugars. That means they have 6 carbon atoms and they have a hexagon shape. They have 6 sides. So going back up, a monosaccharide is defined. Mono means one, saccharide means sugar. So they're simple sugars. They can have 3 to 7 carbon atoms. So if the formula, if they have 3 carbon atoms, it'll be C3H6O3. If they have 5 carbon atoms, the formula will be C5H10O5. Glucose, let's see if the formula is here for you, so I don't have to write it. No. Okay, so, all right, I'm going to use my pen. Hold on a minute. You do need to know the formula for glucose, and so it's going to have 6 carbon atoms. So it's C. Try this again. For some reason, sometimes I just have to do it twice sometimes. So it's C6, C6H. One more time. C6H12O6. That is the chemical formula for glucose, and you do need to know that. So you see how it's a 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. All right, so monosaccharides. We've covered monosaccharides. And then we have some examples of monosaccharides here. You have glucose, fructose, galactose. These are the 6 carbon sugars called hexoses. And deoxyribose and ribose. Deoxyribose is found in DNA, ribose is found in RNA. All right, disaccharides contain 2 monosaccharides chemically bonded, so they're double sugars. They're still sugars, but they're a little more complex than monosaccharides. Important disaccharides are sucrose, maltose, and lactose. Sucrose is formed, you can see it's formed by dehydration synthesis of glucose and fructose. Maltose is formed by the dehydration synthesis of glucose plus glucose, so 2 glucose molecules. Lactose is glucose plus galactose. So those are just examples of dehydration synthesis reactions that form these disaccharides. Make sure you know the examples of monosaccharides and disaccharides. Make sure you know the monosaccharides are glucose, fructose, galactose, deoxyribose, and ribose. And the disaccharides are sucrose, maltose, and lactose. Lactose, of course, is found in milk. Maltose is the sugar that's found in malt beverages, like, malt liquor. And also, like if you get a milkshake and you order it, you order like a chocolate malt, you order a malt. They're going to put malt powder in there. It kind of tastes like those candies called Whoppers. They also have malted milk in there. So maltose is that kind of sugar. And here you can see sucrose is glucose plus fructose, maltose is glucose and glucose, and lactose is galactose and glucose. So all of these are combined from monosaccharides. All right, polysaccharides are the polymers, the long chains of monosaccharides. They are also, just like disaccharides, they're formed by dehydration synthesis, and then they're broken down by hydrolysis. The important polysaccharides for us are starch, because a lot of our nutrients and our food that we eat, our nutrition comes from eating starchy foods. So starch is the carbohydrate storage form used by plants. Plants will take the food that they make by photosynthesis, and that'll be in the form of glucose or fructose, typically, and then they will store those monosaccharides in chains, and it typically will end up in the root of the plant, and that is the starch. So think of potatoes, and carrots. And then glycogen is the storage form of carbohydrates in animals. So in humans, in our liver cells will take glucose from our blood and then combine it into chains and store it like that. And those chains of glucose are glycogen. Okay, so glycogen is like animal starch, basically. Polysaccharides are not very soluble, whereas sugars are. Okay, monosaccharides and disaccharides are, but polysaccharides are not. This shows you what glycogen looks like. It's long branching chains, but each of those individual building blocks or monomers are glucose. Now, the section on lipids. Lipids also contain carbon, hydrogen, and oxygen. And sometimes they'll actually contain phosphorus, like the phospholipids that are found in our plasma membranes or our cell membranes contain phosphorus. But most lipids just contain carbon, hydrogen, and oxygen, but less, I think that should say less oxygen than in carbohydrates. The ratio is different, okay? So lipids are insoluble in water because they form nonpolar covalent bonds. The main types of lipids are triglycerides, or that's body fat, basically. Phospholipids, which form a double layer and form the plasma membrane of our cells. Steroids, which can be cholesterol, is the precursor to all steroids, and cholesterol itself is a steroid. Testosterone, estrogen, progesterone, those are steroid hormones. And then eicosanoids. So triglycerides are called fats when solid and oils when liquid. They're composed of 3 fatty acids bonded to a glycerol molecule. And we'll look at that, what they look like in a minute. They're formed by dehydration synthesis, and main functions are energy storage, insulation, and protection.